Before we get to the main topic of this worksheet, I want to remind you all of a couple of things. Long ago, when we first started talking about radical expressions, we talked about something called the principal square root. And so the principal square root, kind of in short, this is not the full, like, super formal definition, but it's the important stuff. We have that A and B are non-negative real numbers. So that if I take B squared, it equals A, which means the square root of A equals B. So the fact that A and B had to be non-negative was really important. We know that when we're looking for a square root, we're looking for one of two identical factors of a number. So there's no way for A to be negative. There's no way to take a number and square it and get a positive, or to get a negative rather. So the only way you can square a number, whether it's positive or negative, is when you square it, you get a positive result. A negative number squared is positive. A positive number squared is positive. So A had to be positive because no matter what B was, when we square it, we're going to get a positive value. So we just said, hey, the principal square root, A and B are both non-negative. Okay? So keep that in mind because that's going to be kind of the heart and soul of all of this. So back when we were first learning how to deal with square roots, if we had something like the square root of -9, we were prompted to say this is not a real number. And it's not. It's not a real number because there was no way to find two identical factors that when we multiply them, we would get -9. We could get +9, but there's no way to multiply two identical numbers, two positives or two negatives, and ever get -9. Okay. So this was not a real number. Okay. But now we find ourselves in this situation where we have these equations that when we try to solve them, these quadratic equations, we try to solve them, we're going to get a situation where we may have a negative under a radical. What do we do with that? Okay, so that's what this whole worksheet is about. We're going to have what's called imaginary numbers as solutions of quadratic equations. And to sort of build the foundation for why we do this, let's consider the quadratic equation x squared plus 1 equals 0. X squared plus 1 equals 0 is a beautiful quadratic equation, okay? And if we look at this quadratic equation, hopefully your mind is automatically going square root property, because if we can apply the square root property, we can solve it pretty easily. And what's nice about the square root property is you need a quadratic where you can isolate a single variable term that is squared and then set it equal to a constant. And that's exactly what we have here. So if I take x squared plus 1 equals 0, I could set this, I could get the x squared all by itself by subtracting 1 from both sides. It's already set equal to 0, but we want to isolate the x squared. So I subtract 1 from both sides. On the left, that gives me just x squared. On the right, that gives me -1. Well, that looks fine. But at this point in time, we've set the stage for the square root property. Now we would need to actually apply the square root property, which tells us take the square root of both sides. Well, when we take the square root of x squared, we just get x. That's fine. But when we take the square root of 1, we have an issue. So ordinarily, we would take the square root of both sides. We did that. The square root of x squared is x. And then we would want plus or minus the square root of -1. But the issue here is -1 is not a real number. There is no number x that when I square it, I'm going to get -1. No matter what x is in the real number system, what we're accustomed to, x is either going to be two positive numbers or x is going to be two negative numbers when we square it. So x times x is going to be positive no matter what sign x was. So how in the world do we get a situation where we have x squared equal to a negative? And so that's what this sentence right here is kind of alluding to. It says the issue is that we know from a previous section that the square root of -1 is not a real number because there is not a real number x that when squared will ever equal -1. No matter what x is, when you take it and multiply it by itself, you're going to get a positive value. So how do we deal with this situation? Okay, and that's what topic 1 is going to be about. So topic 1 is the imaginary unit I. Some of you may be sort of familiar with this. If not, it's not too bad. So to provide a setting in which equations like x squared plus 1 equals 0 have solutions, mathematicians have invented this concept of complex numbers, okay? Now, we're not going to dive deep into complex numbers at all. You'll probably go deeper into that when you get to pre-calculus. We just want to talk about how to deal with the square root of a negative, okay? So definitions. We have the imaginary unit I, okay? And it is defined by I equals the square root of -1. Okay, so we now have this thing that if you square it, you get -1. Okay, so if I equals the square root of -1, we're saying this is a fact. We're defining this to be so. Then if we take I and square it, and we take -1, the square root of that, and square it, we get that, whoops, we get that I squared equals -1. So these two things right here are really, really important. You need to remember those. So I equals the square root of -1. I squared equals -1. Okay, so make sure you understand these two things. So I'm going to write them out here a little more clear. So I is the square root of -1. If we square both sides of that, we get I squared equals -1. And this is what you must remember. Okay. So let's look at the kind of a more formal definition right here. It says if b is a positive real number, then the square root of -b equals the square root of b times -1, which equals the square root of b times the square root of -1, which equals the square root of b times I. Okay? Now, another definition, and we're not going to get too bent out of shape about complex numbers. Our main goal in this class is just understanding the imaginary unit I. But it says the set of numbers in the form a plus bi, where you have real numbers a and b, and then the imaginary unit I, this is called the set of complex numbers. So the real number a is called the real part, and the number bi is called the imaginary part. Again, when you get into a pre-calculus class, you'll go deeper into complex numbers. For us, we only are worried about I right now. Okay, so let's look at how we can rewrite some radical expressions where each is a multiple of I. Okay, so example 1, it says write each as a multiple of I. So we have the square root of -36. So we could rewrite this as the square root of 36 times -1. That's not bad. And then we have this thing called the product rule for radicals. We talked about this previous chapter, where if you have a product under a radical, you can write it as the product of separate radicals. So we could rewrite this as the square root of 36 times the square root of -1. That's no big deal. The square root of 36 is easy at this point. We know that's just 6. And then we were told right up here, well, we'll scroll. We were told right up here that the square root of -1 is I. So we're going to come down here and we're going to replace our square root of -1 with I. And that's it. So the square root of -36 is just 6I. Okay? Now for part B, we have the square root of -11. So I could rewrite this as the square root of 11 times -1. We can separate that as the square root of 11 times the square root of -1. Well, the square root of 11 is as good as it's going to get. It can't be simplified. There are no perfect square factors in 11 that we could simplify out. So this is just the square root of 11 times I, which we would really just write it as the square root of 11I. Just be really, really careful here. When you still have a radical in your answer, make sure the I is not under the radical. It has to be separated from the radical. And a lot of people worry about this enough to where sometimes you will see this as I square root 11. I'm fine with either one. I'm not going to get too bent out of shape about which format you use. Just make sure your I is not under the radical. I will get bent out of shape about that. All right, finally for part C, we have the square root of -24. We could rewrite this as the square root of 24 times -1. And we know now that we could rewrite that as the square root of 24 times the square root of -1. Well, the square root of 24 needs some work. I definitely have some factors that I could rewrite 24 as. I want to rewrite 24 as 4 times 6. So that tells me I have the square root of 4 times the square root of 6. Don't forget you also have the square root of -1 still. We're just bringing that down. Well, the square root of 4 is just 2. The square root of 6 cannot be simplified. The only factors of 6 other than 1 and 6 are 2 and 3. None of those are perfect squares, so the square root of 6 is just the square root of 6. And then remember, the square root of -1 is I. Now, just like in part B, sometimes people get a little nervous having that I after a radical because the I is definitely not under the radical. It is outside the radical. So you would also see this written as 2I square root 6. Like I said, I'm not going to get too worried about which format. Just make sure your I is not under the radical, okay? So for this, make sure you understand what the imaginary unit is. Make sure you understand why we have it, and then know how to simplify an expression and rewrite it with I in the answer.